Good morning. Welcome back to the course Manufacturing of Composites. I am Dr. Amandeep Singh. I am working as TA with Dr. Ramkumar in this course. So this is the lab demonstration session 1. In this session, we'll give the basic introduction to various kinds of fibers. We'll show some fiber forms and we'll show some kinds of resins here as well. And further, we'll do some fabrication here as well. We'll show various parameters which are taken into consideration while fabrication. For example, pot life, the orientation of fibers, the amount of resin that is to be put, then various parameters. These would be obviously the some specific kind of properties what we need to obtain, what we need to achieve, that would be attained by some specific combinations. So those we'll test in the further sessions. So first I'll start here with an overview of few fibers. Now what we have here is a template that is made to demonstrate the kinds of fibers that are used in composite manufacturing. So in this we have two columns. The first column is essentially the glass fibers and the second one is carbon fibers. Regarding the properties of glass fibers, it is already discussed in the class in the previous lectures. We have various kinds like E glass. E is for electrical it is used for insulation. Then S glass, that is for strength. Then we have C glass, that is for C is for corrosion, that is corrosion resistant glass is there. And you can see that these fibers these are very flexible. And Dr. Ramkumar has also given an assignment to find out why the glass fiber and the glass, that is simple glass, that is manufactured glass, have different properties. This fiber is flexible, the glass is brittle, it breaks and shatters into pieces when you break it. So this is your assignment. It is very simple, reason for that, but you have to just find out that. Now in this, first we have is this roving glass fiber, we call it roving. This is a single thread. This is the only fiber that is one dimensional, I would say. One dimensional fiber, it is used for filament winding, and the second one is unidirectional fiber. This is also used for making other composites parts. For example, it is used in autoclave or some other resin transfer molding and other processes. The other fibers, other three fibers are actually two-dimensional fibers here. We do not have any three-dimensional fiber here. The two-dimensional fibers are there. This is a woven fiber. Woven fiber means it is a woven. It is a kind of a stitch. Like this cloth is there. This cloth has some pattern of. These are kind of different patterns of fibers. So this is a woven fiber. The woven can be it is weaved in a way. It is weaved in a way so that the threads stay together. So the weave can be directional, that is we call it plain weave or a uniform weave. It can be even basket weave, the kinds of weaves, twill weaves. Then we have here we have satin weave. This is kind of satin fiber. Here when this kind of weave is used, the strength rises because this thickness also rises. And this is chopped fiber, also we called it as short fiber. So this is used where intricate parts, where the shapes are there which are difficult to form, because it can attain any shape. We put it in a glass, we put it in any curved shape, it will attain that shape. Next we have here is carbon fibers. Carbon fibers are high strength fibers. The strength is typically 15% more than the glass fiber. Otherwise this 15% is not specific thing. We can have different types of ingredients in this fiber to have different strengths. Now this fiber is a conducting material, and this is also high cost fiber, not high cost, the cost is higher than glass fibers. So this is used to manufacture the parts where strength required is higher. Random fiber, again random kind of chopped, not exactly chopped, but it is a random kind of, the orientation of the fibers is random. Then we have woven fibers, similar to the woven fibers we have here. in glass. The properties of carbon fibers, just recalling, carbon fiber is costly, the cost is higher when we compare it to glass fibers. It is a conducting material, the strength is relatively higher, typically 15% more than glass fibers. Now next we have here is Kevlar fibers. Kevlar fibers are very hard, they cannot be cut by a simple blade. So these are used for manufacturing bulletproof like jackets or some other things. Now next we will move on to our fabrication desk, where we will show you how to fabricate a simple composite. Now next we are going to fabricate a simple composite using, we will select a fiber, we will select a resin here, and we will do fabrication. Now the kind of fiber we have selected is chopped fiber, and we will make a simple sheet of composite of dimensions 200 mm into 150 mm. Now what we have here is, we have cut this chopped fiber into pieces of the required size, that is 200 mm into 150 mm. The number of pieces cut are 4 pieces are cut, and we take it to the casting table. Now in the beaker what we have is resin. Resin that is used here is polyester resin. Now there are two kinds of resin available here. There are polyester and epoxy resins, and as we know, the properties of these resins vary. Now polyester resins, it is important to control the styrene level here. The styrene actually lowers the viscosity, which is very critical, and this polyester shrinks upon cure, that it is facilitating to release from dye. Then we have epoxy resin as well. In epoxy resin, the process is very slow and the reaction rate is also slow. That is gelation period. The gelation of epoxy occurs at a later stage. Now what is gelation? Gelation is when we mix additives and we prepare the polyester for casting. Then there is some time after which the solidification starts. Now before that time the casting has to be done. That is known as pot life, right? That is known as pot life, the life of the pot when the solidification is not there, when it is in liquid state and it is in a usable state. Now when we have mixed various ingredients to have final resin, that is called the glue starts forming here. Now this epoxy, if we use epoxy, that decompose at 250 degrees centigrades, and the fiber that we use here decompose at 1200 degrees centigrades. Resin we have here is polyester resin in the beaker. Now what steps we will follow? We will take two mild steel plates, that is 300 mm into 200 mm into 4 mm, and clean both the plates using acetone and put one of them on rigid surface. Then we will take two mylar sheets. Mylar sheets are smooth sheets of dimensions 320 mm into 220 mm with thickness of 200 micrometer, and we put one of the sheets on the mild steel plate and remove all the dust particles by acetone as well. Now we'll as we have cut the chopped fiber, we'll put polyester resin first on the mylar sheet. We'll take 150 gram of polyester resin, generally we call it GP resin, in a beaker, and we have added 1.5 gram of MEKP, that is methyl ethyl ketone peroxide, and we have mixed it properly by glass stick. After mixing the MEKP, we added 1.5 gram of cobalt octate as an accelerator. What an accelerator does? Accelerator speeds up the solidification process, maybe speed up, maybe slows down. If we add a lower amount, it may be lower speed. Then if we add a higher amount, then the speed might rise. That is why it is called as accelerator. And we started mixing it, and this is prepared in this beaker. And in this mixing, it is avoided to have any bubbles, because bubbles create problem. Like bubbles might create some defects and some other things. Now when final casting is started, we will make a layer on the mylar sheet by resin, then put one of the layer of the chopped fiber over the resin and roll it using a rubber lined roller for its proper weighting. For its proper weighting, the roller is used so as the resin is spread uniformly and the bubbles are all removed or cleared from that. Now, we will keep on adding the layers of resins and fibers to obtain the final composite. Now, this composite would be kept for 12 to 15 hours so as the solidification happens in a good way. Now, here we start the process. So, this is a mylar sheet that is put on here and we use a brush to put on the polyester. Now, we are just putting on the resin. This mylar sheet is used so that the final product which we obtain does not stick on the mylar sheet. Now, first layer of chopped fiber is put on. Now, it is being rolled using this rubber lined roller so as to uniformly distribute the resin and to clear bubbles or some other things. This is the second layer of resin. Now, all the layers of fiber are used here. Now, finally, we will add some more resin here after rolling this final layer. Now the second mylar sheet is put on. The mylar sheets are used for easy release of the composite from the die. Now what we have here is a mild steel rod of 1.5 inch size. Now this will be used to finally clear the extra resin and to have uniform shape, uniform thickness in the composite. Okay, now the casting is completed. Next we put the second mylar sheet and we will put some weight here. Here we took 10 kg weight so as it is compressed and the cast is completed here. Now we will do the similar kind of thing with the other fiber. That is, next fiber we have here is the glass fiber, that is woven glass fiber. We are doing it using two fibers because we will use it for testing further, like we will do tension, compression, fatigue, ILSS, this is interlaminar shear stress, then 3-point bending. We will do various tests for different kinds of fibers. On this kind of casting, we just using the layers of fibers and resin. We could even sandwich some other things. For example, we can use hollow structures between fibers and between faces. We can sandwich like to have more thickness. For example, you can use honeycomb, that is hexagonal structure, or core mat, but that reduces strength. Here we are just preparing a kind of a specimen that we will use for testing. Now, the second mylar sheet is put on. Now, the same mild steel rod is used to finally roll down . Now, this second sheet, MS plate essentially, MS plate and weight is put on. Now, the second casting of the laminate is also done. Next, what we are doing here is, we have taken a curved shape. Curved shape, we will just we have just used this to show that chopped fiber could also attain the curved or some intricate shapes. So, we have chosen this cup for this one. We are adding resin here, then we will add this chopped fiber. It is cut in a shape so as it fully covers the inner surface of the cup, and is all extruding like fibers would be cut after final casting. Now, second layer of resin is put on. Now, we are cutting the extra fiber material. So, we have roughly cut it with a scissor, and we will finally cut this extra layer as well with a blade. And this casting is also like for solidification, for final removal or releasing of the layers for obtained part, 10 to 12 hours are required. So, we will remove it next day. Now, we are here on the next day. Now, we are removing this weight and the MS plate, and these mylar sheets would be removed. Now, we are ready with our final composite. So, in this demonstration, we just had an look over the types of fibers. We had used resin, a polyester resin, then we did fabrication of composites. This process which is used here is known as wet layup process or maybe hand layup process. So, next in next demonstration session, we might take this to a testing lab, and we will do some tests, some strength testing on this one. Thank you.